Welcome students of class 10th DPS Surat. This is the chemistry class. This video is of chapter 1 chemical reactions and equations part 4. By the end of this video, students will be able to understand decomposition reaction, classify the types of decomposition reaction, will understand the different sets of conditions required such as temperature, light, etc. in the reaction, will be able to predict the products formed in the reaction. This video is all about decomposition reaction. In part 3, you must have learned about combination reaction. Combination reaction and decomposition reactions are reverse to each other because decomposition reaction has a single reactant which decomposes into several products. Let's understand through an activity. Heating of lead nitrate. Take some lead nitrate in a clean and dry test tube, which is white in color. Heat it over the flame. Lead nitrate will start decompose to lead oxide. Meanwhile, you will observe brown fumes. If we bring glowing splints, it reignites. Also, yellow color compound of lead oxide will be observed. So, there are following observations. Lead nitrate to lead oxide, yellow color formed. Fumes observed suggest gases are formed. Brown fumes are observed means nitrogen dioxide gas is produced. Glowing splint reignites means oxygen gas is produced. If we write this in a chemical equation form, so PbNO3 twice when heated gives PbO plus NO2 plus O2. So here a single reactant breaks down into various products. Such reactions are known as decomposition reaction. As heat energy is used, this reaction is also an endothermic reaction. So what is decomposition reaction? It is a type of chemical reaction in which a single compound breaks down into two or more elements or new compounds. These reactions often involve energy source such as heat, light, or electricity that breaks apart the bonds of compounds. AB is a reactant which breaks down into A and B. Similar example we can take of NaCl which breaks down into chlorine and sodium. Depending upon the energy used, decomposition reaction can be classified into three: thermal decomposition, electrolytic decomposition, or photolytic decomposition. What is thermal decomposition reaction? Let's perform an activity of heating of ferrous sulfate crystals. Heating of ferrous sulfate crystals. Ferrous sulfate crystals are pale green in color. Take some amount of ferrous sulfate crystals in clean and dry test tube. Heat it over the flame. Initially, you will observe the crystals are decolorizing as water molecules are produced due to the loss of water crystallization. Later, it will turn into ferric oxide and gases of sulfur oxide. These gases can be observed near the mouth of the test tube as colorless white fumes will be observed. These gases are toxic and pungent smell. So, we should be away from these gases. Test of sulfur dioxide gas. How to test the sulfur dioxide gas? Take some potassium dichromate and acidify it with dilute sulfuric acid. It is orange in color. Now add sulfuric acid to acidify it. If we pass the gas, this gas will change orange color of potassium dichromate to green in color. So it suggests that there is a sulfur dioxide gas. Now some more examples of thermal decomposition reactions. As we already have seen, the heating of ferrous sulfate crystals, which produces ferric oxide, sulfur dioxide, and sulfur trioxide. Sulfur oxides are acidic in nature. This can be detected by using blue litmus paper. If we take wet blue litmus paper near the gas, it will turn into blue red in color. Another example of heating of calcium carbonate, which produces carbon dioxide gas and calcium oxide is formed. Calcium oxide is also called lime or quicklime. It has many uses. One is in the manufacture of cement. Now, turn comes for electrolytic decomposition reaction. So, what is electrolytic decomposition reaction? If electricity is used for decomposing a substance, is called electrolysis. When electricity is passed through acidic water, it decomposes into oxygen and hydrogen gases. In fact, water is a bad conductor of electricity. So, we need to add salt or alkali for easy conduction of electricity in water. Dissolve some salt or alkali in the water. Pour this solution in the apparatus. Pour this in test tube also. Make sure that no air bubbles are there in the test tube. Invert these test tube over the iron nails. These iron nails act as electrode. The outer circuit of the electrodes, when connected to the positive or negative terminal of the battery, electric current is produced and hence bubbles are observed in the test tube. Examine the volume of the gases produced in the test tube. After some time, take the test tube, bring the glowing splinter to the test tube which has less amount of gas. The splinter will burn brightly. This suggests that oxygen gas is present in this test tube. Now bring another glowing splinter to the test tube which has more volume of gas. It will burn with a pop sound. Also, it will burn with a blue flame. This suggests that it is a hydrogen gas. So when the process of passing electricity through water and decomposes into oxygen and hydrogen is called electrolysis. This can be represented as 2H2O. When decomposes, it gives 2H2 plus O2. Now, photolytic decomposition reaction. Activity 1.3. Silver chloride is exposed to sunlight. The decomposition of a compound with light is called photolysis. Take about 2 grams of silver chloride in a china dish. It is white in color compound. Place this china dish in the sunlight for some time. It is observed that white silver chloride turns grey on exposure to sunlight. So reaction is silver chloride, white color compound decomposes into grey color silver and chlorine gas. Similarly, you can see the same reaction for silver bromide, but it is a yellow color compound which breaks down into grey, silver and bromine gas. These reactions are used in black and white photography. So such reactions are known as photolytic decomposition. I repeat, white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Note, silver bromide, it is yellow in color. It is also behaving in the same way. It decomposes into silver and bromine gas. These reactions are used in black and white photography. Please make a note. These reactions are used in black and white photography. Now it's your turn, children. You have an assessment for this video. There are 4 questions. Why are decomposition reactions called opposite of combination reactions? Write one equation for each of the decomposition reactions. Why is the amount of gas collected in one of the test tube double of the amount collected in the other? And write a balanced chemical equation when lead nitrate is decomposed on heating. Thank you and have a nice time.